Hello, everyone. I start to my topic. So first to introduce myself, I'm Steve from Intel, works for Intel and Network Platform Group, which belongs to the data center group. So today my topic is about VDPA. Some of you may know that, but I think most of them don't. So the topic is probably you know each of the word, but you don't know actually what it means. So today I want to start from the beginning. So start from the background. What's the background around that? So, okay, you know that I'm working from the network platform. So the problem actually on the end of it is that, so we are good to use just like a PASS-THRU device. So you can easily get the native performance like the NIC provide. So PASS-THRU device to the guest and get that virtualized. But essentially the challenge is that towards the cloud, this is not cloud, this is just virtualized. So the problem is that the interface is hard to either line migration or hard to do dynamic resource allocation or provision, etc. So that's the problem for like PASS-THRU device facing to the cloud ready. So that's a problem. And either that the virtual network appliance actually can choose another choice, which is the like VIRTIO device. So the thing is that, so you hypervisor emulated device, then on the backend side, the virtual switching is run by your software on the core, and we can scale out the core count actually to provide them higher performance to the VNF. But situation happens is that, okay, that is quite good maybe for 10 gigabits switch capability, but what about for the future? Like we want to run more bandwidth workloads on their guest for their like 10 gig, 25, even 100. How about that if the infrastructure spend more cost to do that, how about the cost for the workloads? So how? So we start, we are looking at both sides for the PASS-THRU device or the power virtualized device. But the topic today, I will mainly focus on the power virtualized. So the way we optimize the power virtualized is that we are working on like provider DPDK. So using DPDK to accelerate the endpoint. So like that here. Actually, for the vSwitch, software vSwitch, we have a PMD for the vHost. So actually, we run that in user space and accelerate that. That just works fine. So if we look at the parse, the data, the device control, actually, we use vHost user to talk with Qemu to get the device set up. And on the data path, it's a shared memory. So DPDK POMO driver talk with the guest driver based on that shared memory. This is the way how we work. And then what about that you connect with our hardware device? Actually here is that like you have a SmartNIC. So if that you get a SmartNIC, how's the way to connect with that interface? Let's say if this is a hardware device, what's the way? So this is the vision we want to see is that, so for the next generation virtual endpoints for the VNF, we want this to be our interface, which is cloud ready. But in terms of performance, we would like that I/O can directly talk to the VM, the workloads in the VM. So that basically on the data path, we actually is I/O to CPU. That's our device to CPU communication. Meanwhile, that on the device side, it still be emulates that we can even well support the software backend. So you can easily switch over from a software backend to a hardware backend, and even that to the remote side doing the line migration. So that's the background vision about that. And so that's where we see how to figure out the way to converging both of them. And then I will give a little bit of introduction about VDPA. So what is VDPA? That's a vHost or data parse acceleration. So 2 key points. So remain the device being emulated in Qemu natively, nothing changed and modified. And only that for its backend, for the vHost channel, we introduce a direct I/O. So make a real hardware device can talk with your guest VM directly. So what's the benefit? The benefit is firstly that, so under data plan performance perspective, it can provide our equivalent packet rates. So nothing changes on the data plan. So it's direct I/O through like I/O menu, talk with the guest memory directly. So then on the migration side, line migration side, so basically, we are not introduce any of the new interface even on the backend, vhost backend side. All the things is leverage is existing on the vhost. So like vhost to trigger when to start log the dirty page, when to start to save the vring base and restore the vring base. This interface remains the same, nothing changed. And the last piece is the most important piece is that we would like to make the unmodified VDPA driver just work. So not just only for the 1.0 but 0.95, because the one major change about them is the I/O access. Like one is MMIO, another is port I/O. So that's the things trying to be reserved in the VDPA. So we start this effort actually around DPDK. So we get code upstream on the 80.5, which is the main release, and also get Qemu support, like sort of the extension of the vhost message on 3.0. So that the remaining efforts for that is to getting VOTA MMU support. It's in working progress, so this is the patch, so working progress patch. And I also attached the links to other talks around that VDPA support in DPDK. So this is the background. And then give a quick introduction as how it works in DPDK. So basically in DPDK, we add our selective data path support for the vhost user library. So DPDK has our, DPDK has our vhost user library. So now we extend it to support not only the software backend, the DPDK PMD, but also to support like a driver. So the driver gets the same message from the front end from the vhost user library, and then it will associate that with a socket, the first associated with a vhost socket to get all the message from vhost from Qemu, and then program the device to set up the context. So once the data path context being set up, the device can talk with the front end memory directly. And then we expose these device to our port representer. So that port representer can connect with the vSwitch logic. So under vSwitch pipeline perspective, it is still have that single V port, but you can alternatively choose that is a port representer which have no traffic, no fast pass traffic going to the pipeline, or you can choose a real PMD which order traffic will go to the software data plane. So finally, that we are looking at to limit the hardware dependency like that. If ask hardware to always log in the dirty page, so that's the hardware effort to do that. So we are looking also on DPDK side, we're looking under the way. So even hardware don't have the capability to log that dirty page, we can fall back to the software data path, so that on that time you can switch over to the software data plan and then do migration. So that's the effort around DPDK. And then people may ask, so you already have a hardware volatile interface endpoint. Why not just a pass-through, right? So that's a few considerations. The first one is that we need to support line migration, but that is not just that hardware volatile migrate to another hardware volatile. We also aim to support like how you migrate stock software data plan to our hardware volatile. So vice versa. So from different backend, from different vhost backend to can be capable of line migration each other. So and then we need to address the stock VM issues that most widely used is 0.95 with the poor I/O, which always cause the exception. And then the rest of them is under hardware design consideration. So it's still a software spec. It is good that you have a spec, but it's still not so stable because hardware its iteration is slower, much slower than software, right? We try to reduce the impact to the hardware design. So the ways to do that is reduce the surface, reduce the hardware interface with software. So we are not asking to support a fully function like what I defined hardware. We limit it. So what's the minimal per request? So you limit it just to, I will mention it later in next few slides. And also that from hardware perspective, so host, the features for the guest endpoint actually is not equivalent, not equal to the endpoint on the host. That means a host interface have more functional, actually is not belongs to the guest. So we are not necessary that pass through a device, then you just use the guest function as a host function. Okay, and it's also very tough for that all the hardware vendor just provide like a VDPA device. So then you lose all the difference between different kind of hardware. So you just have a single hardware. So how to support different functions there. And so definitely we are not going to target for a vendor specific. So we want to have multi-vendor support. So we are trying to limit the hardware dependency. So the minimal pull request is that, so of course your DMA controller need to operate on the VRAM. So that is the minimal things. Otherwise you cannot talk with software, right? So others are options. So you can optimize the doorbell. You can map your doorbell to the guest, let it being possible. So like that per queue, you can have a separate page for that. Of course, you can even design other. So backend, under backend design, you can own your backend design, not relevant to always follow the VDPA spec. And okay, so there's a lot of other consideration about data paths, like how we make it faster and bus efficient. That is not in today's agenda, but because we have other DPDK VIRTIO monthly meeting, we can talk about more about that. So today's my talk is more mainly focused on the way to construct the data paths. So okay, so what's the problem? So we already do that in DPDK. Why we are going to present another things today? So that's about problem. So we have data plan on the user space by software. What about all these things done? So why it happens is because that, so when the smart comes in, so people even don't want to have their data plan on the host to minimize or reduce their hypervisor effort. So like all the IOs go to the separate system. And also that on the host, you may have their hypervisor just take off their device management, but no longer supply the IO. So then what is needs in the middle, right? So we still need our intermediaries to connect to the backend with a real hardware driver. So what's the connection? What's the proposal of that? So that's the topic for my talk today. So then we back to revisit the things we are going to have. So first of all, that we have a different type of devices from different vendor. The device interface are quite different. So you can have multiple vendor, different interface. So basically we need our abstraction. So on top of them, so can support multi-vendor. So what's the ideal interface? So like that under VDPA perspective, the vhost already be the natural abstraction for the backend device. And for the device driver, what is the natural user space driver? That's a vfio. So that's why we propose this vhost plus vfio. That is vhost and vfio, right? And so we consider to direct the VDPA to the guest, but that's building around the vhost. So we would like that backend device, the interface, still being around vhost. So here's the thing. So here's the proposal. So we can do that in a few ways like that. We can do that in Qemu with some Hawk, but we are not choose that because so we have other device interface, not just like one VDPA device. So we can do that like in a Qemu, we can introduce a VDPA driver, then add some quicks for all the things I mentioned. But what about other device? Totally, basically, I'm not just a VDPA device. I have a device vendor ID that is Intel or ++ and other features. What about that? So you have a lot of vendor. And that another is that if Qemu take that, what about the control separation? So like that, I still need to leverage kernel functions, TC floors to configure that per representer, how that comes from. And also, host features, as I mentioned, is much more than the front-end functions. We can reduce functions on the guest and make it simple enough and to support cloud. But what about a host interface? So that's why we focus on the kernel like that. We introduce a new channel to be possible to deliver the vhost message, and it's over VFIO interface. So nothing changed on the VFIO user API, nothing changed on the vhost message definition. All things are there, just to introduce a new channel. Yeah, so here it works. So like that, okay. For the things is that we allow us to create that media device by give a UUID, and then give that UUID to Qemu, and Qemu just add a new adapter which called a vhost-vfio to drive that function. Then for the I/O trap and emulation, it still happens. So all things back to the vhost, and turns to be our vhost message, and through the rewrites. I/O rewrites syscore to the kernel VHOST-MDEV. And then if that we are going to optimize the function features that we actually can to register memory slot to the guest to map. Okay, here's the doorbell. I can direct write. And then for the DMA and the intro remapping, and still leverage all the remaining things in VFIO to make that happen. So all these things around. So what is the device looks like? So because VFI PCI is just to use the hardware layout, we cannot change that. So that's why we leverage media device. The good thing is media device gives us the ability to define the software layout. Here's the device looks like. We use 2 bars and 3 memory region, 1 config region, 1 bar 1, and 1 bar 0. So for config space, CSR, it's quite easy. Just to identify I'm the vhost-MDEV. And for the bar 1, we provide ability for you to map the doorbell. You can do that through that bar. And bar 0 is quite easy, just to give you a channel to deliver vhost message. That message already be defined like a request. All the requests, we use the command for I/O control for the vhost net. So we are not invent any new messages. So all the message goes through rewrite function syscore. So for set, we just write that, right? For get, that we write the request and then get for read for the response. So that is a simple device layout. Then what we provide as our helper function. So in the helper function, we provide like VDPA device, which provide the basic function to pass all the vhost message. We provide I/O control, rewrite, unmap, open and close. You don't need to develop by individual device. So what to do for parent device for new vendor? So if you are a new vendor, you just implement like the 2 of the parent ops, create and remove. When you doing the create, you can allocate a VDPA device, and then it should give you a point to that device. And you can use the helper functions to register as some parent device ops. That's all provided for you. And then so you need to implement your own driver. That function is being provided. You need to provide the function like start, stop your device, and to tell what feature you are going to support, and to set up the doorbell, like the base address if you're going to expose to the guest. And then that's all the things you need to do. So quite simple, right? And then what about for DMA Interrupt? We are not inventing new things at all on this in this part. So for DMA setup, we leverage VFIO user API. So basically just call map DMA and unmap. That being handled on the Qemu patch we introduced for the vhost PCI. So, but we have one dependency is that to get the media device to get aware of the IMMU and get that support. And for the interrupt, the same, we using the VFIO API. So, that we, of course, that we support like IRQ PASS-THRU. So that's by our PASS-THRU manager also being covered by the VFIO. So right now, the first RFC just support MSIX, but in the future we will support other interrupts states. So we have 2 key developers on that. Tiwei and Xiao is working either on the kernel patch and also the Qemu patch. Yeah, we send our RFC patch there, so welcome for any comments. So looking at these common infrastructure for our device vendor. And the next step is we are going to provide a driver. The driver we are going to build around is using our VIRTIO NAT device, because everyone can get that. You can use Qemu emulated device for that to enable that function. So that will be a simple device driver for that. And also, we track this and discuss VDPA stuffs in our monthly meeting, which is DPDK VDPA monthly meeting. And any comments and or suggestion, you can join the meeting and we can talk. Yep, that's all the content and questions.
Hi, so great presentation. So what I didn't understand is that the guest is supposed to coordinate the address of its ring with this virtual MDEV device, but the format of the descriptors inside this ring is specific to what the hardware is aware of, right?
Yes, it is.
So it does assume that it only works in case both the guest and the host work, for example, with VIRTIO or with another format. Okay.
Yeah, it is. So the ring layout, actually for the data pass, the ring layout need to follow the spec, because we have an unmodified gas driver. So the only way hardware or software to talk with this front is follow the same exact layouts, operations, either the VIRTIO NAT header. So all that should be there, follow the spec. So
this leads me to the next question of, what is the advantage of using this solution in case if I just use VIRTIO compared to the solution presented by Intel in a previous lecture of having a NIC that knows how to do dirty tracking? Like there was, Alibaba presented here a NIC that from Intel that is FPGA based and implements the VIRTIO interface, but also has the ability to dirty track DMAs.
Yeah, so whether being capable to track dirty or not, it's up to hardware device. So you can, if they can track it, that's good. But so on the software perspective, we need a common interface to hardware, whatever it can support or not support. So even for the hardware not support, we are going to support. So as you see that in DPDK, actually we can fall back to a software data pass. So for the hardware, you no longer to support that. But eventually, if you like that using the kernel driver, so you don't give a fallback parse, actually you have to ask your hardware to support that. But the framework today we are going to introduce is not limit that. So give you the like log base, give you the VHOST already give you the memory to log, like that's bitmap, log bitmap. So we use that. So get that information from Qemu, from the infrastructure, and up to driver to decide. Either it's being handled by the hardware or need a software assistant.
I see, thank you.
Yeah.
Hi, so on the VIRTIO above, lots of people, or some people felt that it might be beneficial to like have a periodic meeting, and I welcomed people to join that on the slide. So I wonder, would you be palatable to kind of just renaming it to just VIRTIO meeting and then like inviting everyone who wants to talk about VIRTIO and not necessarily DPDK? Do you think that's a good idea?
Yeah, that's a good question. Is that so? Here you see today's my topic is for non-DPDK version, right? So right now we have a few kind of separation. One of the separations, like I separate the day plan with all the rest of things. Like, okay, a day plan is running on the card, right? And there's another separation, is separation all the infrastructure, like to support bare metal. So on that time, even the VMM is not there. So, but there's another like separation. So you still have the sort of the data plan on the whole side. You still have the DPDK. So that's why, because of that, as I said, so for the 25 or more bandwidth, for IO bandwidth, so the one VM want to consume that. But a lot of VM actually is the bandwidth is less than one gig. So actually that still can share the bandwidth with others. How to share that? So it's very low cost. Actually, you just spend one core to do the data pass and give the memory. Once that you have a higher like SLA, so you need a high bandwidth or quality, you can easily switch over to that. That gives you a way, very clean way to upgrade your traffic on demand. So that's my personal thought of it. So that's why we're still keeping doing to DPDK support both the software and the hardware.
Okay, thank you. We're out of time.
Yeah. Okay. Thank you.